दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्. Dear viewers, welcome to the online classes in organic chemistry topic, the resonance. We have discussed what is resonance, resonating structures, and how to write resonating structures. This class I will be devoting for the application of resonance. In what are the fields in which the concept of resonance helps to a student of plus 2 science or the aspirants for JEE and NET entrance exam students. Keeping that in view, I will be taking this application of resonance at different reactions or different compounds. So now what are the important applications of the resonance? So the important applications of what are the things, the concept of this resonance helps us in understanding the chemical and physical properties of organic compounds. So it explains, it finds its application in the following. The one is to explain the reactivity and stability of organic compounds. What is this reactivity and stability of organic compounds? That I will be discussing to you. The second, to explain the acid strength and basic strength of compounds. Basic strength of compounds. Then third, it explains the dipole moment. There are some compounds, they exhibit dipole moment, and dipole moment of some compounds are more or less than the other. Dipole moment, the boiling point, melting point, these facts are explained. The bond length, of inorganic compounds. So this resonance is a very vast topic which the students of the plus 2 science read, a student of chemistry honors also reads, then a student reading in MSc also reads. It's a continuing process, but my lecture that I am keeping in view to the student of all the subjects that they are in our plus 2 syllabus and also our JEE, that NET, JEE main, JEE advanced syllabus. Now let's come to this. What is this? First I'll discussing about this reactivity. What is this reactivity? If it come to a compound, one compound is more reactive than the other. or one compound is more stable than the other. So if you come to resonance, what happens in the resonance? The delocalization of the pi electron take place in the same atomic kernel produces a resonating structure. So because of this delocalization of this pi electrons, on certain atoms positive and negative charges are created. So if in a resonating structure, and if you see the resonance hybrid, if the those resonating structures which are ionic, they will contribute towards reactivity of the molecule. And this resonance hybrid, these two resonance hybrid, that we get, they will stability of the molecule. So when those resonating structures which are purely covalent, non-ionic, or the complete delocalization take place, there is no charge separation, they are stable. We will taking the examples and discussing them, so you can very easily understand, but I am giving a concept which I am going to consider this. Now then we will come to the acid strength and basic strength of compounds. What is this? If you come to alcohol, exhibits as if it is an acid, because acids react with the metal to produce nascent hydrogen. Alcohol produces nascent hydrogen, so also carboxylic acid produces nascent hydrogen, but alcohol is neutral, the carboxylic acid are acidic. Why? Question comes to a student of second year, a question will come in the exam, ethyl alcohol is neutral whereas acetic acid is acidic. Or he may give the dissociation constant of acetic acid is 1.8 in 10 to power minus 5, whereas that of ethyl alcohol in the order of 10 to power minus 18. Explain. Or if you come to the phenol is acidic. Nitrophenol is more acidic than phenol. Like these questions you will be having. Same thing the bases. If you come to the aniline, we have C6H5NH2 is a base, is an organic compound. Aniline is basic. Or may question come, alanine is less basic than ammonia. We have read in inductive effect, methylamine is more basic than ammonia. But if you come to C6H, that is CH3NH2, but if you come to C6H5NH2, it is less basic than ammonia. Why? Such questions it is explaining acid strength and basic strength of the molecules. Then coming to dipole moment. Because what happens? Because of delocalization of the molecule, of the pi electron and on the atomic kernel of the molecule, we will have a positive charge at point and negative charge at point. So the molecule will exhibit dipolar character, and that dipolar character, because that dipole will have a dipole moment. So if you have the same class of organic compound, we will compare the dipole moment of the molecules. The boiling point, melting point, they can be explained by this. In certain, if you come to the isomers, if you come to a ortho isomer, para isomer, meta isomer, so which will have the higher boiling point and a higher lower melting point or a higher boiling point, that can be explained. Bond length of the molecules. For example, if you come to benzene, the bond length, carbon-carbon bond length in benzene is 1.4 angstrom minute. So in benzene we find all the bonds are double bonds. Carbon-carbon double bonds. But you have read in alkene, it is 1.3, but it comes to 1.4. Why this happens? Such things which are there in our syllabus in different organic compounds we are studying. So I am just giving an outline of different organic compounds just to give you a concept of this resonance, how it helps. But when I will be going into the compound, particular compound, alcohol, aldehyde, ketones, carboxylic acids, there again I will be explaining the important questions that can come in both NET, JEE, main or our NET exam, basing on this acid strength, basic strength, dipole moment, reactivity of the molecule. For example, alkenes undergo electrophilic addition reaction, whereas aldehydes and ketones, they go nucleophilic addition reaction. So such things are there that can be very easily explained by concept of resonance. So children, I will be requesting you one thing, try to make a practice of writing the resonating structures of all the compounds that is there in your syllabus at one place. Write first carboxylic acid, aldehydes, ketones, then come to phenol, aniline, then benzoic acid, benzene diazonium chloride. All these compounds are there in our syllabus. Try to, at one place, you try to write the resonating structures of the compounds. So if you do 3, 4, 5 times, your hand will be free and you will be learning many things about that. So let us now, I will come to first explain you the acid strength of the compounds. I will explaining you the acid strength. I will focus on this because in our plus 2 syllabus, second year students, they begin with a oxo compound alcohol. And alcohols are neutral where carboxylic acids are acidic. See, this is a question comes, many often a question comes in a plus 2 student in board exam, he may have a question, and alcohol is neutral, whereas carboxylic acids are acidic. So now if you come to alcohol, in case of alcohol, ROH is alcohol. So in alcohol, what is there? The oxygen electronegativity is 3.5, hydrogen is 2.1. So there is always a drift of electron towards oxygen. So oxygen gets a delta negative charge and hydrogen gets delta positive charge. So this alcohol has a tendency, this bond is partially polar. Since partially polar, it creates instability in the molecule and oxygen has a tendency to attract the pair of electron. So this pair of electron will come towards oxygen. So this dissociates to produce RO minus alkoxide ion and the H plus ion. So this reaction is supported by which reaction? Now if you take alcohol ROH and treat this with the sodium, then it forms sodium alkoxide RO minus Na plus and H nascent hydrogen. This is called sodium alkoxide. Sodium alkoxide. So RO minus is alkoxide, Na plus, sodium alkoxide and H. That means it is those compounds which donate proton or those compounds which have replaceable hydrogen atom are acids. So alcohol has this property. So one may think that alcohol is acidic. Now we will tell that, now we are going to confirm that alcohol has a tendency to lose H plus but is not acidic. It is rather more neutral than water. Water is neutral and alcohol is more neutral than water, that we are going to say. So what will happen now? If we apply the law of mass action, the dissociation constant KROH will be what? Concentration of RO minus into concentration of H plus by concentration of ROH. If you go this, so this comes in the order 1 into 10 to the power minus 18. The dissociation constant of alcohol comes 1 in 10 to the power minus 18. Whereas the Kw, the ionic product of water, concentration of H plus into concentration of OH minus is called ionic product of water, is 1 in the order 10 to the power minus 1.4 in 10 to the power minus, this is 10 to the power minus 14. So what that means the concentration of H plus ion is much less than the concentration of H plus ion in water. This comes as, if you come to concentration of HOH, this concentration of H plus in alcohol is less than that of water. That what you mean, those compounds which give H plus, they are acids. That means alcohol, the H plus ion, concentration of H plus ion produced by alcohol is much less than that of water, and alcohol is more neutral than water. Then question comes, why? Now because it produces the alkoxide ion, alcohol produces this alkoxide ion. This alkoxide ion, Ro minus, has a strong tendency to attract proton back and to form ROH. Why? Now this alkoxide ion is a base. It acts as a base, a strong base. The alkoxide ion acts as a strong base, has a strong tendency to attract the proton. That means the proton it gives, who? Alcohol gives, no doubt, but takes it back again. That means alkoxide ion is not stable. Is not stable as Ro minus, again it reacts with H plus to become ROH. So what is an acid? Those compounds which give H plus are acids. So alcohol is not giving H plus that much. So water has 10 to the power minus 14 and it has 10 to the power minus 18. This shows as the dissociation constant is a measure of acid strength. So alcohol is more neutral than water. Now let us come to carboxylic acid. If we come to carboxylic acid, in carboxylic acid is RCOOH. Somebody may ask, sir, why are you writing the structure of this? Because a student of chemistry knows the carbon atom is in sp2 hybrid state. The carbon atom is in sp2 hybrid state. When the carbon atom is in sp2 hybrid state, the bond angles, this bond angle, this bond angle, these bond angles are expected to be 120 degree, approximately 120 degree. Hence, I am writing the structure like this. Then, if you come to this, what is this? Here, oxygen has two pairs of unshared pair of electron, and here it has two unshared pair of electron. And here is a tendency, because the electronegativity of oxygen is more than hydrogen, so there is a tendency for oxygen to get delta. So there is a tendency of the pair of electron to come to oxygen. And what is this? Here one bond is a pi bond, and this bond is a sigma bond, and this pi bond is a pi bond. The electronegativity of carbon is 2.5 and that of oxygen is 3.5. So here there is a electromagnetic effect. We have studied electromagnetic effect. When the carbon atom is bonded to an atom of higher electronegativity and there is a pi bond and sigma bond between them, then the pi electron cloud gets delocalized towards the oxygen. Oxygen will pull the electron pair towards it. Hence, there is a tendency for the electron pair to go towards whom? Towards oxygen. And as there is tendency it goes, then what will happen? Carbon will develop positive charge. So in the carboxylic acid molecule, the carboxyl carbon always has a tendency to have a delta positive charge. It has a delta positive charge. Means what? There is a deficiency of electron. If there is this deficiency of electron, then the electron will flow to this. But here there are two lone pairs of electrons in where? In the oxygen atom. Hence one of the lone pair of electron moves to this place. Do you understand this? The one of the lone pair of electron will move to this place. So then what will happen? The delocalization of lone pair of electron take place. Hence the carboxylic acid exhibits resonance. So now this is the two lone pairs were there. One pair of electron came here, and here is the oxygen and here is hydrogen. And now because this carbon atom, this oxygen, and there is, this becomes a double bond, and now this oxygen atom gets a positive charge, oxonium character. The oxygen atom of the carboxylic acid, it develops it becomes what? Oxonium Oxygen with positive charge is called oxonium. Carbon with positive charge is called carbonium. So here is this has a positive charge. So this has a carbonium character. This develops a carbonium character because of drift of pi electron pair between carbon and oxygen to oxygen. And to neutralize this positive charge, there is a flow of electron. This pair of electron of oxygen gets delocalized. So and now there are two structures for these are the resonating structures of carboxylic acid. Now if we write its resonance hybrid, then what will the resonance hybrid? R C O. I told you always you write the sigma skeleton. You write the atomic kernel, then write where the electron has flown. So electron movement took place from this place. So there is a movement of the electron took place. So here we got a delta negative charge. Here we got a delta positive charge. So this is the resonance hybrid. So because of resonance, the carboxylic acid molecule exists in an ionic form. Here is an ionic form, and there is a charge separation in the molecule. I told you those molecules are ions, are those resonating structures. If there is a charge separation, here is a positive charge and here is a negative charge, so there is charge separation in the molecule, and that charge separation will create reactivity in the molecule. So this will always try to become neutral or to have one charge in the molecule. So what I mean to say here, the resonance hybrid of carboxylic acid has a tendency to lose a proton. How? That means it will neutralize this positive charge. This can neutralize this positive charge. How it can have that positive charge? So this hydrogen atom can come to this, lose its pair of electron to oxygen. So automatically it will give a double bond. So what happens here? Now if you come to this ionic structure of carboxylic acid, we have this, and here we have OH, and here there is a positive charge at the oxygen atom, and so always hydrogen has a tendency, so there is always drift of electron, sigma electron is coming to this, so this pair of electron will come to neutralize this positive charge, hence we get a molecule here R C O with the negative charge, 3 lone pairs of electrons and the double bond O, and this is called carboxylic acid, carboxylate ion and H plus. That is the reason why carboxylic acid in presence of water has a tendency to lose proton. So to lose a proton to produce carboxylate ion and H plus. So this carboxylate ion has no charge difference. So there is no, here is a negative charge and positive charge. Two charges are there. So this is unstable. Charge separation unstable. Here is no charge separation, only one negative charge. So I mean to say here the carboxylate ion is more stable than the carboxylic acid. So in presence, if you take a carboxylic acid molecule, if you take the carboxylic acid molecule and in presence of water, so now this water is accepting the proton lost by the carboxylic acid molecule. Hence carboxylic acid loses a proton to produce carboxylate ion and H plus ion. Now if we can say that the carboxylate ion is stable, carboxylate ion is more stable than carboxylic acid, then our answer comes, the carboxylic acid donates proton, forms a carboxylate ion, the carboxylate ion is stable, hence the carboxylic acids are acidic. Now if you think about the carboxylate ion, so I think you have understood all this. Now I will come to take the carboxylate ion and concentrate what is happening on the carboxylate ion. So the carboxylic acid molecule has a charge separation. At one oxygen has a negative charge, the other oxygen has a positive charge, oxonium character. So H plus is lost to form the carboxylate ion. Now if we come to carboxylate ion, RCO minus, this we got, and this is the carboxylate ion, O. Now this negative charge, so this here, if you come to this bond is a sigma bond and this bond is a pi bond. So here is a negative charge, lone pair of electron and the pi bond. So there is a conjugative effect. They are conjugation. They are in conjugation. They are in conjugation. So automatically this oxygen will be attracting the pi electron pair towards it and will produce a positive charge at the carbon atom. To neutralize this positive charge, this pair of electron can come to this place. So this carboxylate ion, the delocalization of the oxygen atom of the carboxylate ion takes place and produces a resonating structure like this. So these are the resonating structures. These are the resonating structures of carboxylate ion, of the carboxylate ion. Then if we write the resonance hybrid, what will happen now? R, C, O, O remains. Now there was a negative charge here. So this came to this place and got the negative charge. So there is a movement of the negative charge from this oxygen to this oxygen. So whole carboxylate ion now gets the negative charge. So this is the resonance hybrid. We get the resonance hybrid of carboxylate ion. So in the resonance hybrid of carboxylate ion, the negative charge is delocalized. Just like a chalk, if I can say that, this is one oxygen atom, this is another oxygen atom. Suppose the oxygen atom has a negative charge. Now the delocalization took place. This oxygen atom got the negative charge. Now this does not have the negative charge, positive charge. Now proton will come. Proton has been lost. The proton is coming to the carboxylate ion. So the moment it want to come to this carboxylate ion negative charge, the carboxylate ion, the negative charge comes to this oxygen. So this negative charge comes from this oxygen to this oxygen and proton cannot be attached here. Now this negative charge again comes to this oxygen. So there is the negative charge is no more there. So the back protonation is not possible. The carboxylic acid undergoes dissociation to produce the carboxylate ion. The negative charge of the carboxylate ion gets delocalized, exhibiting resonance. Hence, the back protonation is not possible. Back protonation is not possible, or the carboxylate ion is resonance stabilized. Carboxylase ion is resonance stabilized. Hence, the carboxylic acids are acidic. If you take the example of, say, acetic acid, CS3COH, the dissociation and formic acid, if you can, dissociation constant of formic acid, if you take, its K comes to 17.7 into 10 to the power minus 5, and the dissociation constant of acetic acid comes to Ka comes to 1.8 into 10 to the power minus 5, whereas of alcohol ROH, this KROH dissociation constant comes to 1 into 10 to the power minus 18. So now you can consider what is the gulf of difference in the value of dissociation constant. The carboxylic acid are acidic. So we will say now, just to complete this sentence, I can say alcohol dissociated to form alkoxide ion donating proton, but alkoxide ion is strongly basic, so attract the proton and back protonation is possible. Hence alkoxide ion cannot exhibit resonance and is not resonance stabilized. There is a probability of coming back to alcohol, but carboxylic acids dissociate to produce carboxylate ion and H plus ion. the negative charge of the carboxylate ion gets delocalized, exhibiting resonance. The carboxylate ion is stable because the negative charge is delocalized. So any fact is delocalized, hence the carboxylate ion is resonance stabilized. So the carboxylic acid is acidic, whereas the alcohol is basic. Alcohol is neutral, or rather more neutral than water. In next class, I will be talking to you why the dissociation constant of formic acid is more than that of acetic acid, or we say formic acid is more acidic than acetic acid, and we can explain what happens to acid strength of the carboxylic acid along the homologous series. When you go from formic acid to acetic acid to propionic acid, etc., along the homologous, what happens to acid strength, we will be discussing in our next class with respect to resonance. Thank you very much.